Okay, let's dive right into your mission briefing. Your objective: to create a technical report on quality and process improvement that is going to knock this assignment out of the park. And this explainer right here, this is your guide to making that happen.
So right off the bat, you're not just a student here. The brief puts you in a professional role. You are a quality engineer at a cutting-edge manufacturing company. So you need to think like one, and you need to write like one. Get in that mindset and you're already halfway there.
So what's the core mission here? Simple. You're putting together a technical report that shows you've totally mastered quality and process improvement. Now this briefing is going to laser focus on those first two critical tasks to make sure you start off strong.
So here's our game plan. First, we'll nail down your role. Then we'll dive deep into task 1 and master the fundamentals. After that, we'll tackle the stats in task 2. And finally, we'll talk about how to deliver a report that really stands out. Let's get into it.
All right, first things first. We've got to lay the groundwork for your report, and that means getting a handle on the fundamentals of engineering quality. You get this part right, and believe me, everything else just falls into place.
When it comes to defining quality, you can't just, wing it. You need to build your definition on the work of the absolute giants in the field, people like Crosby and Jurin. And you got to ground it in industry standards, like ISO 9000. That's how you show you're not just guessing. You really know your stuff.
Now this slide, this is basically your secret weapon. It gives you the complete framework for your whole analysis. As you look at each one of these 7 M's, I want you to ask yourself a question. How does this factor affect the quality of something like, say, an electrical circuit board? That's how you turn a generic list into a really sharp analysis.
Okay, so we're shifting gears a bit now, moving from the theory to the real world. I want you to imagine you're right there on the factory floor. How do you make sure every single component rolling off that production line is absolutely perfect? That's what we're digging into next.
Think about it like this. 100% inspection is like proofreading a book by checking every single letter. It's incredibly thorough for sure, but man, it costs a ton of time and money. On the other hand, sampling is more like just skimming the chapters for obvious typos. It's way faster, way cheaper, but yeah, you might miss something. Your job is to break down those trade-offs.
All right, time to get your hands dirty, so to speak. Your report needs to analyze these 3 instruments like you're actually deciding which one to use on the job. What are they good at? What are their limits? When would you grab a micrometer over a caliper? That practical, hands-on kind of thinking is what's going to make your report shine.
And now, for the main event, Statistical Process Control, or SPC as we call it. This is where you get to be a quality detective. You're going to use data to find hidden patterns in a process and figure out how to make it even better. Let's do this.
So let's set the scene. You've got this CNC machine and it's just churning out these metal shafts. The big question is, are they all being made correctly within that super tight tolerance? Your mission is to use the data to find out the truth. This is where you really get to show off your analytical chops.
And this is your raw data. 4 samples, 5 measurements each. I know at first glance it might just look like a bunch of numbers, but trust me, hidden inside that table is the secret to understanding exactly what this process is doing. Your job is to unlock it.
And here it is, the million-dollar question. Is this process actually in a state of statistical control? Is it stable? Is it predictable? Your analysis is going to be the final verdict, so you better make sure it's backed up by some solid evidence from the data.
This is your playbook. Seriously, your step-by-step guide to nailing this analysis. Just follow these 4 steps exactly in this order, and you are going to produce a rock-solid piece of work. So, go ahead, grab your calculator, and let's get started. All right, so you've done the heavy lifting with the charts, but now you've got to connect the dots. How does all this number crunching actually fit into the bigger picture, the company's entire quality system? That's what we're going to break down now.
I love this comparison. Think of it this way. Quality control, or QC, is kind of like being a firefighter. You're reacting to problems, running around putting out fires after they've already started. But quality assurance, QA, is like being the fire inspector. You're proactively checking the building's design to make sure fires don't start in the first place. Your report has to show you get that crucial difference.
Okay, we are on the home stretch now. This is our final debrief. Think of it as a last-minute check to make sure you have absolutely everything you need to deliver a top-tier report. Let's make sure you're set up for success.
And this right here is your pre-flight checklist. Seriously. Before you even think about hitting send on that report, go through this list item by item and check off every single box. A single missing piece could jeopardize the whole mission, so you've got to be thorough.
And never, ever forget your real purpose here. You're not just writing a report to describe things. Your role is to be an agent of change. You're evaluating these systems to find ways to make them better, to reduce waste, and to improve efficiency. That's the real power of a great quality engineer.
All right, the briefing is over. The mission is officially in your hands now. So go on. Take what you've learned here, apply it, and show everyone what a top-tier quality engineer can really do. The future of quality is up to you.